Isn't it weird how a glass of water doesn't have any color, but large amounts of water in the ocean are blue? Even though 70% of our planet is covered by water, surprisingly few know the exact nature of the ocean's color. You may think there is a super complex reason for this, but while the science can be difficult, we've made it really easy to understand in this video. Even if you have the attention span of a 5-year-old, we'll make sure that next time you're at the beach, you can wow your friends with newfound knowledge and gaze at the ocean in a brand new way. To understand why the ocean is blue, we first need to understand how different things get their colors. This begins with our eyes and how they perceive light. White light, like sunlight, is made up of all colors mixed together. You can think of light as many small rainbows. To make it easier to visualize how light brings color to things, we'll give each of the colors its own shape. When light hits a surface, each color or shape is either absorbed or reflected. Think of a surface like this toy. Each surface has a unique set of shaped holes in it. When light hits a surface, the shapes that fit are swallowed, making them disappear. The other shapes are bounced off the surface. In our eyes, we have mini color agents that scout for colors bounced off different surfaces. When they spot a color, they signal the brain about the surface it's bounced off from and what color it is. For example, a green apple has holes that swallow all colors except green. The green that is bounced off gives the apple its color. If it's a red apple, all colors except red are swallowed by its surface. If multiple colors are reflected off a surface like red and blue, our brain mixes them together and sees purple. With this knowledge, we understand that the ocean absorbs all colors except blue. However, in some places, the water appears more blue than in others, and in some places, the water looks green or even brown. So, is there a flaw in how we perceive color, or is there another explanation? Rather than being a fault in the way we perceive color, this has a perfectly logical explanation. If we inspect blue water closely, we'll see pure water, which reflects the color blue. If we take a closer look at green or brown water, we see contents like algae or sediments. This changes how the water interacts with light, altering which colors are absorbed and reflecting more of the green or brown color. But this still doesn't explain why a glass of water doesn't have any color. If pure water reflects the color blue, then a glass of pure water should appear blue, right? There is a common-sense reason behind this as well, and this is the final piece of the puzzle to fully understand how water gets its color. We're back to the surface with holes in different shapes that swallow and bounce off colors. The surface of a glass of water only has a few of these holes because of its small volume. When all these shapes of colors hit the surface, it causes a traffic jam, and even some of the shapes that have fitting holes are bounced off the surface. When colors of all kinds are bounced off and mixed together, our eyes perceive it as no color. Remember, white light is made by combining all colors. This is why a glass of water appears colorless. In the ocean, on the other hand, the water is in a much larger volume, and its reflective surface has millions and millions of holes. When they work together in such large numbers, they can collect all colors that have fitting holes, leaving only blue to be reflected back to our eyes. More water simply means more blue. But remove light and all color disappears. We see nothing. To help us see when the sun cuts its workday short, we invented the light bulb. But how does it work? Find out how leftover scraps became one of the most important inventions in human history by watching this video.